third order correlation function. So we have 3 velocities, but we have only 2 positions. So not that there are 3 different positions. We have, please recall, we have r and r plus l, r plus l. So these first 2 ui uj, so there are 3 indices I, j, m. So first 2 are at position r, ui, uj, and third one is at um prime is the second point. So it is a correlation of 3 velocities, but at 2 different points, important. Now this comma separates, this comma is separating the r with r plus l. Okay, so this is the notation. Now prime means the second point. Now again we can, so we discuss how to consider second order tensor, but now we can do third order tensor with this. So it is only function of L. So given L, you can consider, or n. Now n is non-dimensional, n is a magnitude 1 unit vector. So you can easily make a guess ni, nj, nm, right. So L1, L2, Li, Lj, Lm. Given the delta function, how do I consider delta ij, nm? So these 3 indices, right, ij, m. But here you see ij is in the left, ij has come here. Now I can also have im, I can do this one im, but then j will be here. But ij are symmetric, right, I and j are in the same platform, but m is a different thing. So if I have im, then I must also have jm. So that will be jmi, ni. Okay. Now al and dl are the coefficients which and fl are function only of L. Al and dl are not equal. Why? Because there is asymmetry in ij with m. Is that okay? So this is how we construct higher order tensors. So this is the third order correlation function. Now my unknowns are al, dl and fl. Now for second rank tensor I had this nice interpretation, velocity like this, but now third rank is not so nice. I mean, of course we have 2 velocities here and third velocity here, 2 velocities here and third velocity here, like that. You can consider, but there are more combination. Here, I mean, that had only 6 components with 3 of them being 0. Why it's 6? Why didn't I say 9? Is symmetric. Okay. Here I have 27 components. Okay. Some will be 0 and so on. Okay. So we can construct. Now this is, I can also now do the derivative, incompressible condition. So incompressible condition will act on prime when I do L. So that is why I have acting on m. Okay. Now that will, once I apply this in condition on thisCijm, do algebra, then you will get some relations, and these relations are the following. It tells you how d and f are related with a and a prime. So I can write this d and f in terms of a. So instead of having more variables d and f, we can write in terms of a using this condition. So basically I have a and al. So theCijm can be written in terms of al and a primes, which is quite convenient. Okay, so this is our third rank correlation u. Now I define third order structure function. Now what is it? It is a difference in the velocities. Now please remember I have this 2 position r and r plus l. So I have difference in velocities. So this is along I component, along j component, along m component. I made one mistake, there is no prime here. Okay, fine. So it is the difference of the velocity, but I am taking the components along I. So I is 1, it means x component, I 2 is y component. So it is again 3 indices object. but now it is there is no comma there. Okay, it is a difference. The difference is same for all of them. So, there is no comma, and my notation is this q, and that was c. Q is structure function. Now, I can expand this in terms of correlation functions. So, what will I get? I get prime prime prime. So, I think I am not going to write. So, this is how the 4 terms are. So, how do I get this term? 2 primes and third is not prime here, or 2 here and 1 prime. Okay. So, I made one mistake. This correlation should be outside, this one should be outside. So, we can get this stuff. So, you see 2 primes and third is unprime. No, so I made one more change. J equal to I make j equal to I. If I make j equal to I and expand. So, is Ij. So, it will have all the combination 3 primes, 2 primes and 1 unprime, all no prime. So, this is how we get. Okay. Now, this you can see it yourself. I will not bore you with the details, except that 2 terms, all the 3 prime terms is not there, right. So, I do not have the term of the form ui prime, uj prime, ui prime, um prime, where I equal to j, and minus ui, uj, um. Now, since I equal to j, this is not present in this. Why is it not present? Is 0 because of homogeneity. Because if I do the triple product, and that should be same at 2 different positions, like so average is. But what is the average of u? Ui average? What is the average ui? 0. It is a random with no mean flow. Average velocity is 0 at a position. Okay, and this need not be 0. Is 0 for Gaussian probability, but this need not be 0, triple correlation. But they cancel because of homogeneity. Okay. Now, this is what we are left with, this average. Okay. Now, we would do one more step. I take the derivative of this with related to Lj. So, what do I do when I take derivative? What happens to this term? This term goes to 0, because I take the incompressible condition, and I forgot to tell you that this also will be 0. There is a proof, and the proof is okay. Proof is kind of nice proof. So, I have f and g prime. I take with related to prime. Let us call it del I derivative. Okay, f g prime, this one, right, is a function of this function of L. So, I take on this. Now, we can write this, since it is homogeneous, I can write this is f of r, f r plus L. I do not know, green is not visible properly, or it is okay, because there are too many red I have written. So, I want to, so this can be written as r minus L into g of r. I shift left. So, this r, so I just shift left by L, and now I am taking derivative with related to L. So, this is r minus L. So, I can't take derivative with g now, I take derivative to the f. So, it will be minus sign with Li. The minus sign comes because it is shifted to the left. So, if I take the derivative with the first object, then put a minus sign. Now, here I want to take with Lj. So, that means I want to take derivative on this one, right, this is j, that one. So, this is that I make this minus sign. So, this minus sign comes here, this minus becomes plus, and this goes to 0. So, this property is also used quite often. You want to shift the point, then you have to use the minus sign and finish it off. Now we are left basically with these two terms, and these two terms equal to that. Okay. Now this proof I will again well no this, so these two are gone because of incompressible condition, you are left only with this, and this is what is written here. Is that okay? So the derivative has come here. I put a prime, put a prime, this is plus prime, and this should be, this is this prime, okay, is acting on these objects, is acting on these objects. By the way, please note that this j prime, if this prime was not there, it will be 0. If I take the derivative, if this prime was not there, it would have been 0. This prime is there, which is making it non-zero, this part. There are some subtleties which when you do it yourself, then you will find that okay, Kolmogorov was indeed very clever and he could do all this stuff. Now, so what is definition of QII? QII is j equal to I here, j equal to I. So that makes it square, no? I am summing over I. So this becomes ui prime ui square, that is u prime square, u prime minus u squared. Repeated indices are to be summed. So this is delta u I delta ui sum. So this is coming from here, and this is u prime m, but I am now taking the derivative with respect to the same object. That means it is a divergence. So that is why I put divergence L u prime minus u. So this divergence is acting on this. Well, it is acting on, because there is a prime here, it acts on all three. So this L is acting on all three, not only one. But I am just writing a shorthand, it is a nice vector notation. So because of this, I am taking the derivative of uj del j, this one, so I write like that. Okay. So this is shorthand notation, which is convenient notation. Okay. So what I described very quickly, third order correlation function and third order structure function, and this object will appear in now Kolmogorov 4/5 law. This you have to remember, this one. Now I need one more step which I will quickly go through. S3. So we are all describing only S3, but third order structure function, but this is very specific. So this was, that was Q notation. I had put Q I J M, no, I J M of L, but now I am defining S3. So this is, sorry, I must say this is a new function I am defining S3, which is I equal to j equal to m equal to 1. So do this one. So 1 means along the L direction. So I am choosing the same notation. The x axis is along L direction. So this will be delta u, I should really put a vector u, delta u component along parallel direction. Is that fine? So I have these two positions. So velocity component along that direction, difference qubit. So this is what, remember I started my first slide, Kolmogorov basically is relating this object with the dissipation rate. So we can define using the third order structure function, but it is very specific. My components are 1, 1, 1. Now it is connected with A, remember third order structure function, third order correlation function had A, D, F. Now this I will not prove it, but this is equal to minus 12A, because see the connection, structure function is connected with the correlation function, and correlation function is function of A. So that is how it comes, is minus 12A. This is a connection of structure with correlation. Okay. This I will not be able to do it, I mean this is too much algebra here. Now QIIJ is again related with A and A prime, it is like this. So you have to plug it in, because and replace D and F by the formula, and you will get this. Okay. Now, I am just giving you the steps, you have to work it out yourself. So, this is one is basically this object, no, Qij is basically is just that I just showed you in the. So, this is square coming from Ii and J and this. Now, remember S3 is well not S3, in the earlier slide there is a divergence of this object, yes. So, you just see there is a divergence of this. So, if I take the divergence of that, which is very useful quantity, which I am going to come to it a bit later. So, I take the divergence of Qij. Now, I think I wanted to do it, but I will skip the algebra. If you do the algebra because it's only bit of algebra, and you will get this one. So, this one is related with S3. Now, it is not, I mean, look, this is function of, is quite, I can just tell you the minus 4 1 by L squared d by dl L square L a prime plus 4a. Okay. So, this is coming from the previous slide. Now, I am sure you are tired, and you can see that this object is 4 L a prime plus minus 16a minus 4 L. So, I have in the earlier slide I have shown. So, this I computed from, this is third order structure function. Okay. Take the divergence of it. So, divergence will be in spherical polar coordinate. Now, this I want to emphasize spherical symmetry. So, what is the divergence in spherical polar coordinate? Divergence of vector A, it is 1 by L square d by dl L square AL component. It has only AL component. Okay. So, that is why this is along L direction, yes or no, u prime u is along L direction, isotropic. Okay. So, this is what has we get. I think I am losing, I mean everybody is losing interest, I think. Anyway, let us finish it off. So, this is a connection of this object which I need in my derivation to this third order structure function. Okay. So, I stop with this, and now we quickly go to the last lab. Okay, thank you.